As a young man back in Costa Rica, Franklin Chang Diaz was inspired by the moon landings and decided that there was no doubt that he wanted to become an astronaut. Well, a kid with meager means living in Costa Rica that didn't speak any English could never ever become an astronaut, right? Well, we wouldn't be talking to him now if he hadn't. Dr. Chang Diaz has managed to earn a PhD from MIT, flown on 7 space shuttle missions, and has managed to invent and develop a plasma rocket that can potentially shorten a 7-month mission to Mars to only 39 days. Now, I spoke with him here at his Ad Astra laboratory in Houston. Dr. Chang Diaz, how are you?
How are you?
Good to see you. Johnny Alonso, 360.
Good to see you.
Thank you. Let's cut to the chase. So, what was your life like in Costa Rica? And, what inspired you to pursue a career as an astronaut?
Well, I was a pretty normal boy,
Yeah,
just growing up in Costa Rica and also part of the time in Venezuela. I actually lived in 2 countries.
Yeah.
I was fascinated by space. I was one of those kids that was fascinated by Sputnik, the launching of Sputnik and the beginning of the space age. And
Yeah.
I guess I decided at an early age that I wanted to be a space explorer. And later in life, as I was getting close to the end of my high school, I decided that it was time for me to start thinking about the future.
Yeah.
And that's when I decided to come to the United States.
Once you finally flew on your first of 7 missions, was the experience everything you thought it was going to be?
It was everything I thought it was going to be and more. And
Really?
even more. Actually, it brought me memories from when I was very little.
Okay.
I used to play as an astronaut in a cardboard box where my friends and I would get inside, and we had chairs which were laying flat on their backs. And we would go through a whole countdown and launch, and we'd go out and explore a distant planet and come back about the time for dinner.
Really?
And I, sitting on the space shuttle about to take off, I thought I'd done this before. I've been here before.
Really?
And of course, then we went, and it was awesome. It was the most amazing experience that you could imagine.
So, you retired from the astronaut corps, and you've developed this new spacecraft, right, that can change travel. Tell us a little bit about it, man.
Well, in space, things are really far away. Things are really far away. Mars is a long ways away, and really the rockets we have today are really not suitable for that sort of travel.
Okay.
And I always felt that we needed to come up with something different, something much more powerful, much more capable, much faster.
Sure.
If it takes us, 8 to 10 months to get to Mars one way, that's too long. It's too long for the astronauts to be cooked up in a spacecraft for that long. We need to go there fast. And because Mars is not going to be the only place we go, we also want to go to Jupiter and Saturn and Neptune, and we're going to explore their moons. And we really want to have access to the entire solar system. So we've been working on this rocket engine, which we call Vasimir. It's a plasma rocket.
Wow.
It uses the stuff that the sun is made out of, the very hot gas, which we call plasma.
Okay.
Temperatures of millions of degrees. At those temperatures, the rockets are able to push a lot faster, a lot better, a lot more efficient. And that's what we're working on here. We got one right here in the back.
This is it behind us.
It's sitting inside this vacuum chamber, and we fire it from time to time.
Right.
We're getting ready to take it up to the space station and put it up there and test it up there.
Really?
Yeah.
So, what kind of testing are they doing on the space station? I mean, can you break it down for us a little bit?
Well, yes. I mean, the sort of testing we have to do in these kinds of rockets, they need to be in a vacuum.
Okay.
Right now, we have this vacuum chamber,
Right.
and this is a big can, it's a big tin can, and,
Yeah.
and we take all the air out, and we make a little space in there,
Sure.
and so we put the rocket and test it there. But when the rocket fires, it destroys this vacuum that we've worked so hard to make, and so the little pumps that are trying to pump the air out are working really hard. So
Gotcha.
eventually the rocket completely obliterates the pumps, and the pumps can't keep up.
Oh.
We have to test these rockets in space, in the real environment where they are going to operate. And that's why the space station is so important to us.
I see.
It is the only place where these kinds of rockets can be tested.
So tell me, what is the difference between what we have now compared to what you were building for tomorrow?
What we have now are chemical rockets, rockets that use chemical fuels
Okay.
that combine and they make a lot of heat. But the problem is that we have to carry a lot of fuel with us. You see the size of the rockets that went to the moon and to take the astronauts to the moon, gigantic rockets, and most of that was fuel. What actually got to the moon was a little tiny capsule, and what got back to Earth was even smaller. So these rockets are real gas guzzlers,
Right.
and they don't get very far. So what we need to do is develop rockets that are more frugal, use much less fuel, and that's what this rocket does. So typically, a chemical conventional rocket will take about maybe 7 to 8 months to deliver a crew to Mars. The plasma rocket can do it in just over a month, maybe a little bit, maybe exactly a month.
Really?
So, but of course you need a lot of power. We are very excited here. We've been working on this technology for now almost 30 years. And we feel that we are now at a very important moment because the conditions of interest now are for completely new technologies. People are now thinking, let's really dream again. Let's really go and open up what NASA used to do, which is to dream and to really move the frontier far out. And we are in a very good position now to participate in that dream. We feel that, sure enough, the development of advanced plasma rockets and very high power capabilities in space will really open up the entire solar system for human exploration, something that we really believe here in our team, in our operation. And we hope that that first human being that will be walking on Mars is a member of our team.
Maybe
hopefully.
you.
Well, if not me, somebody else.
Listen, thank you for your time. Gracias para todo.
Mucho gusto.
Mucho gusto, sí, primo. Nos vemos pronto.
Nos vemos pronto.